The overall goal of this procedure is to apply minute-scaled intermittent hypoxia to microscaled pancreatic islets to investigate preconditioning effects. This is accomplished by first fabricating a multimodal microfluidic device with a thin gas permeable membrane. The second step is to create a computerized oxygen modulation system. Next, islets are carefully loaded into the device and then liquid and oxygen microfluidics are connected. The final step is to coordinate microscopy with the multimodal microfluidics in order to visualize the islet parameters that are changed during the oxygen modulation. Ultimately, the islet intermittent hypoxia technique is used to show that glucose response is clearly impaired in hypoxia, while temporal modulations of hypoxia can train islets to respond with less impairment.
The main advantage of this technique over existing methods like dissolved oxygen or using a hypoxic chamber is that accurate oxygen concentration could be delivered to the islets in rapid, minuscule time intervals without shear stress from complicated flows. It also allows real-time monitoring with fluorescent microscopy.
This method can help answer key questions in the islet transplant field, such as defining hypoxic impairments in transplant sites or preconditioning regimens to improve transplant outcomes.
Though this method can provide insight into islet hypoxia, it can also be applied to other tissues and systems, such as the central nervous system, cardiac tissues, the kidney, and other transplant organs.
Visual demonstration of this method is critical, as many of the device fabrication and islet handling steps are difficult to learn because of the novel interdisciplinary nature of the technique, but aren't inherently challenging when familiarized.